When I say different router types, then I would say, okay, so I'm having a router which is at the border of the two areas. Okay. So I'm having router at the border of two areas. I will call area border router. Then I'm having a router which is inside an area. And then it may be backbone, which is one class of areas, and that's this other class of areas, which is any other area. Right? So once I do that, then I have to define what it is. Area border router. So another thing before I go there, once you have a router, let me put a note. So this is a note that it is an interface of a router that is a part of an area, not the entire router. Right? So when I'm drawing this router, it doesn't mean that this particular router belongs to any area. No. Interface. So I will be having an interface which will be leading into the green area. I'll be having an interface which will be leading into the yellow area. So not the entire router is part of any area, rather one of the interfaces of the router is a part of an area. So based on that, based on this, then we can define area border router. We would say area border router is any router with at least one interface in area 0. If you have a router that has at least one interface in area 0, that router will be called area border router. So in this example, so these two routers, let's say R1 and R2, so they are area border routers because each of them has one interface in green. They are area border. Now for those routers who are inside the area, so they have two categories. If you have a router which is having all interfaces, inside an area, and obviously this area is not backbone, I will call these routers internal routers. No, here I would write, right? Oops, internal router. Right? So for example, this router, which is part of topology, which I have not drawn, I have all the interfaces in yellow. Let's say R3, R4. They both are IRs, internal routers. Now the definition of the inside in an area router in backbone is a little tricky. It is the same definition. The same definition as ABR. So technically, ABR is also a backbone router, and they are called backbone. This will be called an internal router inside a area 0 would be called backbone router. So ABR is also a backbone router of special type. What is speciality? Not all the interfaces are in area 0, right? So, so for this, let's say this is R5. So R5 is backbone router, but R1 and R2, they are backbone routers, but they are special type of backbone routers because the definition of backbone router says any router having one interface in the area 0 is a backbone router. Why is this definition so? Because if that router doesn't work, the network would not work. But then ABR is a type of backbone router, BR. But if you are given ABR and you are given BR and you are asked to mark BR, you must mark BR because that is a better choice. If no BR is given and you are asked to mark a BR, then you can mark an ABR because obviously that is a type of BR. Right? So then I ran into doing all that work. Now in RIP, routers are routers, but now in here, I'm looking at it's an ABR, it's a BR, it's an IR or whatever. Why? Because I decided to make areas. As soon as I decided to make areas, I ran into this problem. Okay, so this is only one step toward defeating the broadcast or reducing the harmful effect of broadcast. Then I said, but there are certain networks. So step 2. There are certain networks, so that is for, so then what it drove me to, in RIP, I would have network is a network, does not matter. But then I have to examine certain networks. So then I said, oh, there are various networks or network types. For example, I can have a point-to-point. I can have NBMA. I can have like a bus broadcast type of network. Okay, so I can have a point to multi-point network. Then I have to look at different types of networks, how they work. Because now I am trying to imagine, okay, which are the networks which are sensitive to broadcasting? When I put them like this, then I identified this and this. Oh, these are the two networks which could be impacted by broadcast more. Then I said, I should do something. So whenever these networks come and they are working on OSPF, what I should do so that I can further reduce the impact of broadcasting. Then I said, you know what? I should bring in the concept of distance designated router. I should bring in the concept of designated router or DR. I said, if it is one of these two, it's a broadcast or not broadcast multiple access. If I am an OSPF network, in here, instead of everyone sends broadcast to everyone, why not I have a DR and everyone, these are different routers, and this is one of the routers, which is DR. Everyone sort of broadcasting to everyone else. So instead of everyone broadcasting to everyone, let's everyone broadcast only to DR. So imagine if there are 30, 40 nodes and everyone is sending messages to everyone. look at the amount of the traffic. And imagine if 30 out of them there are two special routers, and 28 has to just talk to that designated router. And then if one need to communicate to the other, they can communicate through that designated router. So in this, then I came up with this idea, oh, I should do one of the routers to be designated. And this is another way for certain network types I can reduce broadcast. Those types are broadcast and NBMA. So then I have to come up with a mechanism of electing a DR. We will talk about that later. So once I have a DR, then we're saying, okay, what if everything is now dependent on one? I'm becoming a centrally dependent on DR. If my DR fails, what happens? I say, yeah, that's a problem. So I should have some redundancy. Then I say, okay, you know what? When I have DR, I should also make someone backup DR. So if my DR dies, then backup DR would come and it should do the process. So I did all. So then in my protocol, so when I was writing the software of OSPF, then I included making of the areas, then identifying which router type it would be. I spoke about some of them. I didn't speak about some of them. We'll speak in future. Then I have to see, for certain types of networks, for example, broadcast type, Ethernet type networks, I can make a DR. Then I said, if I have to make a DR, I have to make a procedure how to elect it. And then I said, for redundancy, I need to see if that dies, who should come up, the BDR. So then I did this arrangement just for reducing the harmful effects of broadcasting.